Welcome everyone to today's webinar about Geobody interpretation in GVERSE Geophysics. As most people watching this probably know, GVERSE Geophysics is the seismic interpretation solution for geographics, and Geobody interpretation is a brand new feature in GVERSE Geophysics that we are introducing with our latest 2019.2 release. And with it, you can create a new type of interpretation data that you can pick on your seismic, and it lets you save areas in your data that have similar seismic characteristics as three-dimensional objects we call geobodies. Now, we have designed it so that the workflows are really straightforward. You can either track a signature automatically through your volumes or create your geobody manually, but this simple workflow has the potential to add a whole new aspect to your seismic interpretations. Right, so how do we go about picking a geobody? Well, everything you need to start working with geobodies is found in the new Geobodies tab of our ribbon. The picking workflow is almost identical to the existing picking workflows for our other interpretation data types, like horizons and faults, in that you create a new geobody, set it as active, mark your seed picks, and then using those seeds, generate the actual geobody. So now I'm going to take you through an example and show you exactly how to mark your geobodies. I have a seismic section open here, and you can see a big bright spot right here. I also have an average energy attribute volume loaded into my interpretation, and you can see that the bright spot really stands out when I view this section from the average energy volume. To get an idea of the extents of this bright spot, let's turn on a probe and render that as a volume. I have that open in a second 3D scene. I can fill this probe up with data from the average energy volume and then use the selective transparency tool to make all amplitudes with low average energy values transparent. This way, I can see right through the probe and actually visualize the extents of this bright spot and its vertical thickness. To save this bright spot as a geobody, you can automatically track this signature, this amplitude range in the average energy volume, and then generate your geobody to save it in the interpretation as an object. To achieve that, the first thing we must do is to create a new geobody. You can do that from the quick add option in the ribbon, and it's as simple as providing a name and a color that you like, and that's about it. Next, we're going to mark some seeds. We have a couple of ways to do it. You can use the polygon pick mode to create a polygon around the regions you want to track, or you can use the brush mode. I'm just going to first undo the seeds that I just added. You can mark your seeds using the brush mode, which lets you just paint over the area that you want to track. You can add as many seeds as you want, of course, but when you're tracking the body automatically, you don't really need a whole lot of seeds. You can think of the seeds as a starting point for your search through the volume for a specific amplitude signature. So even a couple of seeds will do, as long as all the samples in the geobody fall within the amplitude range that you want to pick and are connected to each other. You can also afford to be a little sloppy, so don't worry about spilling over the edges. That's because when you go to generate the geobody, you can define the amplitude threshold you want to include in your geobody. The histogram here shows you the data distribution of all the seeds that I marked. I can use this histogram to define my amplitude threshold, and since I'm interested in all the high and average energy values, I can move the max slider all the way to the right. This will ensure that all samples with high average energy values are included in my geobody. Since I was not very careful about the edges when marking my seeds, for the minimum value, I'm going to adjust it so that it excludes any low amplitude values that may have snuck into my seed picks. When I click Generate, my tracker will run through the volume and include all points that fall within the amplitude range I defined into my geobody. I can also limit the extents of my search using these controls here. I can select a probe displayed in any of my scenes or put down a custom range limiting the search to any subset of my survey. After I've defined my threshold and extents, I can click on the Generate button to start the geobody tracking. It starts out with the seed points and first checks if each seed point falls in the range. Even if it is a seed point, if it falls outside the amplitude range, it is not included in the geobody. Next, for each qualifying seed point, it checks the neighbors of that seed point in each direction, front, back, left, right, top, and bottom. If a neighbor falls in the amplitude range, it is included in the geobody, and so on, until we find a point where none of the neighbors fall within the defined amplitude range. Using this process, the amplitude searches through the volume and spits out our geobody. And you can see the body it tracked right here. I'm going to copy this to the second 3D view to see how it compares to the bright spot that we were looking at earlier. As you can see, it's a pretty good match. Almost exactly what you see in the volume has been included in the geobody. except for the second piece right here. And that's because the connection between these two pieces probably falls outside the amplitude threshold that we defined when we were generating this geobody. If I go back and regenerate my geobody and use the same maximum limit but a lower minimum limit and run the tracker again, this time you can see that the connection between the two pieces also falls into the new amplitude range and is therefore included in the geobody. Alright, so that is how you can automatically track a signature through the volume, define the amplitude threshold, and have the algorithm come up with a geobody of all samples that are connected to your seed picks and lie in that amplitude threshold. We also have a workflow that lets you manually create your geobody. There are several scenarios where this is useful, but one of the most common ones is when you are picking a channel. I have a time slice from the semblance volume open here, and you can see this channel going right through over here. To pick this, first I'm going to create a new geobody. Let's call it channel and give it a nice color that will make it stand out a little. I'll go with yellow. I have my empty geobody now, and I'm going to set it as active and then mark my seed picks along the channel that I see right here. The brush pick mode works really well when picking channels. You can just follow the channel along on your time slice. There is another channel right here. I'm going to paint that in as well. I'm going to now navigate to the next section. I can see both the channels going through this time slice as well, and I'm going to mark these picks as well. I can adjust the size of the brush so that my brush strokes match the channel with width more precisely. When creating a geobody manually, I have to be a lot more precise with where I draw my picks, because unlike tracking through the volume, we are now going to interpolate all the picks that you mark here and save them to the geobody. So you want to be sure you're only including areas in your picks that you want to be a part of the geobody in the end. Once I have all my picks, I can generate the geobody. This time, instead of tracking, which will not really work very well in this particular case, mainly because the picks cover the low semblance of the channel edges and the higher semblance of the actual channel itself, there is no real amplitude threshold range that will give us a reasonable geobody automatically. So I will use the interpolation option instead. This will take all my seed picks exactly as I marked them, and hence the need to be precise, and interpolate them to create a geobody, which is our channel system displayed right here. And there you have it, two very straightforward ways to add geobodies to your interpretations. And once you have the geobody, whether through interpolation or tracking, you can draw data from any seismic volume available in your interpretation onto your geobody. From the display settings, choose the seismic option as the display type. It defaults to the data version used to generate the geobody, but you can pick any available data version and data from that volume will be draped on the geobody. I'm going to put data from the amplitude volume on here to see how the actual seismic looks like on the geobody I extracted using the average energy volume. I can also display a geobody as an intersection with vertical or horizontal seismic sections. Use the on section only option in the display type to view how the geobody intercepts a plane, whether it's an inline, crossline, or a time slice. This helps me understand the spatial and temporal extents of my geobody at a particular inline, crossline location, or at a constant time in case of time interpretations, or a constant depth in case of depth interpretations. Finally, you can calculate an estimate of the volume enclosed by the geobody. In time domain interpretations, we must provide a way to convert the time values to depth. You can do this by using the active velocity model to get the velocity values required for the conversion. Alternatively, if you have a good idea about a representative velocity value for the geobody, you can also use that constant velocity option and provide a hard value for the velocity of the entire geobody. You're not limited to a single calculation for any one geobody. You can use different velocity models or a series of different constant velocities for your calculation. Calculation history is saved as part of your interpretation and is always visible in the volumetrics window whenever you access it using the volumetrics button in the Geobodies ribbon. Geobody picking is a powerful new addition to the GVERSE Geophysics set of tools. We hope you'll find this, along with a host of other new features that we have introduced in the 2019.2 release, useful when interpreting your seismic data in geographics. Thank you for your time in attending today's presentation.